Hi, I'm Don Alfano, Director of Applications of Isolation and Machine Interface Products for Silicon Laboratories. Silicon Labs has a long history of developing disruptive new technologies that enable innovative products, such as the isolation products that you'll see today. In this video, we will reference three different isolation products. Our Si8540 series of 2.5 kV and 5 kV digital isolators offer as many as 6 forward-reverse isolation channels in a single package. Unlike opto-couplers, these devices have parametric stability over the entire operating range of -40 to +125 C and VDD range of 2.7 to 5.5 volts. Silicon Labs digital isolators are 10 times more reliable than opto-couplers and offer substantial gains in size, timing performance, and power savings. Our Si8500 series of isolated half-wave AC current sensors offer low-loss, high-accuracy current measurement for switch-mode power systems operating between 50 kHz and 1 MHz. These products use a novel inductive sensing technique and on-chip signal conditioning for low-loss, high-accuracy current measurement. These sensors are smaller and more efficient than current sense transformers and Hall devices and require no external components other than a VDD bypass capacitor. Our Si8230 series of 2.5 and 5 kV ISOdrivers use the same advanced isolation technology as our digital isolators, but add half amp or 4 amp peak gate driver output circuits. These ISOdrivers have fast 60 nanosecond propagation delay and none of the speed or timing limitations of gate drive transformers or optocouplers. They are also faster and more robust than high voltage gate drivers. Also, the Si8220 series of ISOdrivers can replace optodrivers and benefit the user with vastly improved timing performance, high reliability, and substantial power savings. With these products, the days of bulky gate drive transformers, wandering optocoupler parameters, and marginal current sensor performance are over. Best of all, Silicon Labs offers an evaluation board that enables the user to gain first-hand experience with this isolation technology. The open-loop point-of-load board demonstrates the ISOdriver and AC current sensor in an unregulated switch mode environment and is available from Silicon Labs using the part number shown below. The architecture of this board is simple. The heart of the system is an Si8234 ISOdriver driving a simple open-loop buck converter power stage. 2 AC current sensors measure the high side and low side switching currents. There is also a non-isolated Si8540 DC current sensor in series with the output load. The ISOdriver is here and has a 5 kV AC current sensor on the high side MOSFET drain. It also has a 1 kV current sensor on the low side MOSFET source. The DC current sensor is connected in series with the output terminal. Here is the board connected to the test setup. We're using an external pulse generator to provide a 400 kHz PWM waveform to the ISOdriver for demonstration purposes. Looking at the board waveforms, the top trace is the ISOdriver high side output. The second trace is the output from the low side AC current sensor. The next trace is the output from the high side current sensor, and the bottom trace is the output from the DC current sensor. As a simple demonstration, I will increase the duty cycle, and you will see a corresponding increase in output voltage on the voltmeter. I now hold the duty cycle constant and I increase the output load. Note the DC output current rising as load is increased. Also notice the absolute magnitude of the AC current sensor output signals. These signals are about 800 millivolts at roughly 1/3 of the output current. Let's see a Hall effect sensor do that. For all you gate drive transformer users out there, the ISOdriver operates over the full 0 to 100% duty cycle. And for all you optodriver users out there, The ISOdriver has a worst-case propagation delay of 60 nanoseconds over the operating supply and temperature range. We hope you'll take a closer look at these exciting and innovative isolation products and try our evaluation board. Thanks for watching.